New Mexico say to expect a milk shortage after Winter Storm Goliath killed more than 30,000 dairy cows. That's hard to believe. That's not all. Storm causing road closures, and that kept truck drivers from transporting the milk that they actually were able to get. Hundreds of loads were lost, and making matters even worse, the storm prevented some farmers from milking their cows every day. When that happens, they start to dry up. Unfortunately, so does our milk supply. Experts say we could feel the effects for up to a year.
Well, you've probably heard a lot about the El Nino that's going on right now. Now we can say that this El Nino has tied the previous record for strongest El Nino on record. You remember the last one back in the late 90s, 1997? There was a lot of talk about El Nino back then. It's actually kind of when that term started to become popular. But the one we have going on right now, you see it's very similar. Now, what are you looking at here? I know, I get it. Those are departures from average temperature of the sea surface temperature in the Pacific, specifically close to the equator. And this is the definition of El Nino. You hear a lot of wrong terms thrown around like, hey, this is an El Nino storm or something like that. No, El Nino itself is when the water close to the equator in the Pacific gets a little bit warmer than usual. That is the definition of El Nino. Thing is, it has a lot of different effects on different parts of the world during different seasons. Now, the one thing we're going to notice the most from this one is
I gotta hand it to these meteorologists. I'm always amazed at what kind of stories they come up with to distract people from the actual weather. Dairy cows. I'm not trying to downplay the significance of 30,000 heads of cattle being killed, because that is a lot of money, and that is a lot of life. And then, of course, we get the El Nino explanation that's packed into all of, it's under 1 minute, I think. I think that's actually under 1 minute. And that's when it's not sped up. Now, back in July of 2015, when Kansas suffered significant flooding, I took the liberty of asking NWS Kansas City meteorologists. As you can see, their reply was less than helpful. So then I took the liberty of posting a gift that I made of the actual College of DuPage weather satellites that clearly shows an enormous amount of water just springing up magically from the center of the continent, where there are no oceans and where the sun could not have possibly generated that much water in that short amount of time. Obviously, I got no replies, and I haven't gotten any replies from them since. In this image, I've highlighted the Pacific Rim water vapor generators, and I want to draw your attention to the location of these water vapor generators. Clearly, something is out there generating a massive amount of very cold water, very fast, and in the same locations like a band. And if you were to transpose this image onto a globe, you would find that that band, this Pacific Rim water vapor generators band, lines up strangely with the area that these meteorologists are calling the El Nino zone. I find that very coincidental. In these images, I've highlighted the water vapor being generated along the Gulf Coast and up a good deal of the eastern seaboard. The dates are at the bottom. What happens when they release this hot water vapor is that it condenses as it rises, and it cools, becoming rain, and then falling downwind or wherever the direction of the wind carries it. You might have also noticed the very unnatural cloud patterns forming across the continent, up near Washington, and across the Bible Belt. I've had a few people ask me, what exactly are wet surface air coolers? And can you help me understand how it is that they are generating this massive amount of water out in the Gulf if there are no power plants? So, I've taken the liberty of procuring a commercial explanation of what they are.
The Niagara Wet Surface Air Cooler, or WSAC, is a heat removal device used to efficiently and reliably cool or condense various liquids or gases. One way of describing how a WSAC works is to compare it to a typical shell and tube heat exchanger. A shell and tube is a sensible cooling device where the process stream being cooled is on one side of the tubes and the cooling water, normally from a cooling tower, is on the other side. If you remove the shell, expose the bare tubes, spray water and induce air over the tube surfaces, you now have an evaporative heat transfer device known as a wet surface air cooler. Here is a typical wet surface air cooler system. The process stream to be cooled or condensed flows inside specially designed tube bundles. Water is sprayed over the outside of the tubes, and air is induced over the bundles in a co-current direction using fans. The cooling effect takes place at the tube exterior surfaces through latent or evaporative heat transfer. The saturated air and water mixture then makes two 90-degree turns, slows down, releasing any large water droplets back into the basin. The warm saturated air is finally discharged up at high velocity through the fan stacks. Niagara wet surface air coolers are designed with a co-current downward flow of air and water over the tube bundles. Co-current flow ensures that the spray water forms a uniform film around this exterior tube surface. This differs from counter-current flow systems where air comes from the opposite direction and can dry out the underside of the tubes, causing corrosion and fouling. The wet surface air cooler does not use plastic fill or packing which can trap dirt and debris. Large particles such as sand, dust, dirt, and leaves are allowed to wash through the tube bundle and are filtered out in the basin. This prevents particle buildup on the prime heat transfer surface. Minimal maintenance is required to keep the tube's surface clean. The wet surface air cooler is a rugged industrial strength unit built to last the test of time.